So, you want to make a pit stop. This is the detailed assembly video for the PitStop extruder for Prusa printers version 1. If you haven't seen the assembly summary video and the bill of materials video, feel free to check this out first, links in the description. I will be adding corrections for this assembly video in the description, so check there first for any notes or changes. I might provide written instructions in the future. Check the description for any links in case I do provide them. This video is quite long, so I've labeled each section and added links for each of them in the description. Use the links to jump to specific sections. The whole assembly can take a few hours. On the computer, use the spacebar to pause and the left arrow key to seek backward 5 seconds. You can use angle brackets to change the playback speed. Once you go through the installation, while the experience is still fresh in your mind, please take a moment to fill in the quick survey I've made. I want to improve the design and assembly process and would love to learn from your experience. If you encounter issues at any point, again check the video description for suggested ways to get help. Now to the assembly instructions. Let me first start with the obvious and remind you that you are following this assembly guide at your own risk and are fully responsible for the results and the whole process. The PitStop design is offered as is. It will probably run better, but could also run worse. There are no guarantees. The installation is reversible. You should be able to revert back to the original setup at any point. Make sure to not damage or lose any of the original parts. The exception is wire extensions, which, if done wrong, can render some parts unusable. You may have to solder back the original fan connector if you decide to cut it. I will not be providing guidance on reverting back to the original extruder. First, we need to do some initial checks before starting. Make sure that the printer is a Prusa i3 Mark III's or Mark III and you have the Mark III's upgrade. Check the description to see if Mark II's or Mark 2.5's are supported, as I haven't tested those at the time of this recording. The MMU2S multi-material unit is supported, the full bare frame is supported, the uncompressed IGOS dryling bearings are supported. This upgrade includes steps for replacing the X-axis and Z-axis bearings, in case you want to do that. Now, word of caution with these bearings: they can produce smoother prints, but they are also more sensitive to build errors. If the rods are not perfectly aligned or something is not straight, it can lead to calibration errors, which are not fun to troubleshoot. If this is your first time modifying the printer, I suggest skipping all the optional parts and replacing only the extruder without the bearings and sticking with the stock X-axis. Stock printer frame should be supported, but I haven't tested it personally, so check the description for any notes. Make sure you have all the necessary printed parts and double check the whole bill of materials. I strongly recommend printing a second set of parts as pairs just in case one breaks during assembly, so you're not forced to revert back to the stock extruder just to print a broken part. If using the bare frame upgrade and the revised X-axis, make sure to print my adapted revised X-axis version because the revised X-axis is incompatible. This requires more screws and possibly a different idler and dowel pin. Check that the idler tensioner fits inside the X-idler printed part. Use a file or chisel if necessary. Check my bill of materials video for the adapted revised X-axis. If using the bare frame upgrade, the universal Zaribo Einzi box comes with a fan cover where the 40mm fan can be used together with a fan grill. There are steps for installing those if you have them printed, or you can install them later. You should now break off the supports on the cable holder. Make sure the zip ties are thin enough to go through the cable holder holes. Carefully remove supports from the motor plate using some pliers. It's important for the surface to remain relatively flat, otherwise you won't be able to mount the extruder motor correctly. Make sure you have purchased all the necessary parts: screws and nuts, magnets, 60mm fan, radiator, etc. It's all in the bill of materials. You can print the included M3 screw helper sheet to organize the screws, but try not to bump into it by mistake. We'll be reusing the 40mm idler tensioning screw installed in the stock extruder. You will have to either use a compatible and long enough fan extension cable, or will have to solder one. I'm not going to cover wire soldering in this video, but I will be covering a wiring alternative not requiring the soldering step, because imperfect soldering can be worse than no soldering at all. Check that the parts are flat. The carriage, the extruder body and the motor plate parts should lie relatively flat. The extruder body and the motor plate should fit and align relatively well. A little bit of distance at the bottom is not a problem. If you have a spare E3D extruder or a spare E3D cold end, the round radiator, check that it fits in between the extruder body and the motor plate. It should be a tight fit for the cold end when pressing the printed parts against each other with some force. You should be unable to move the extrusion column at all. The two printed parts should have a very little bit of play between themselves, as if the cold end is a little too big. The play should be about 1 mm or less. Ideally, you'll barely notice it, but it should be noticeable. Otherwise, the extruder might not stay fixed during printing. If in doubt, I advise not to proceed any further. It can help to move the Z-axis up to make it easier to manually take out the X-axis assembly. To do this, in the printer menu navigate to Settings, Move Axis, Z-axis and select around 150 mm. Leave enough room at the top to be able to easily disassemble the extruder. Make sure you can easily access the electronics board. Now turn off and unplug the printer. Make sure the printer is physically unplugged. Have the Haribos nearby and access them whenever you start feeling frustrated. Every time you access the Haribos, make sure you don't consume more than half of what's left. This way you will never run out of Haribos. It may be a good idea to have a recent print on hand to use for a before and after comparison. These are all the initial checks. Now take a moment to play with the new magnets. We'll start by unplugging and disassembling the extruder. Cut the zip ties holding the cables on the cable holder. Completely remove the textile sleeve. You'll have to open the case for this. I've got this alternative case. You might still have the original. Completely disassemble the extruder. I don't have the stock extruder here, so I can't show exactly what to do. Remove the belt, all screws, the sensor, the idler hub gear, carefully not to lose tiny parts, fans, and the E3D extruder block. Be careful with the electronic parts as they can get damaged. We'll need a small M2 screw holding the infrared sensor in place for the new extruder. The heating cartridge wires are delicate and can break near the cartridge when bent, so be careful. Open the mainboard case and unplug all wires going to the extruder in order to remove the printed part. I don't have that part installed, so I can't show it to you. Just disassemble as much as you can at this point. If you didn't have a spare E3D extruder or cold end, this is a good time to do a final check that the extruder fits in between the extruder body and the motor plate. Be careful with the extruder wires. It should be a tight fit for the cold end when pressing the printed parts against each other with some force. The two printed parts should have a very little bit of play, as if the cold end is a little too big. If in doubt, do not continue with the upgrade. At this point, only the bearings should stay on the rods. Remove all the wires and electronic parts from between the rods. I've got a PitStop part here remaining, but the original extruder should disassemble completely. Haribo! Oh, I don't eat animals. Are you an animal? Now we need to remove the X and idler. First remove the two Z-axis top parts. I've got a bare frame here, should be similar with the stock frame. Remove the X-axis assembly from the printer. Either dismount the Z motors or remove the screws holding the trapezoidal nuts for both Z motors and unscrew the nuts. This last part is required if you're also replacing Z-axis bearings or the X-axis ends. Unplug the X motor if necessary to avoid breaking its wires. Now remove the X and idler from the rods. It'll be hard. Try wiggling it while pulling or use whatever method works. Remove the bearings from the rods. Haribo time. If you plan replacing the X-ends with the adapted revised X-ends, for example, then completely remove the rods. Unplug the X motor and take it off the printed part and install it on the new part. Remove the idler from the other printed part and install it on the new idler adapter. Make sure to use the correct idler adapter. You may need a larger internal diameter idler and a 5mm thick dowel pin or piece of screw. Stock idler wheel can be used instead. If you can't find the right parts, revert back to the stock X-ends. Remove the bearings from both printed parts. Insert the rods in the part with the X motor. You can use a bit of grease so they go in easier. If they don't fit in, use an 8mm drill bit to adjust the holes. Don't drill too deep. You now have the possibility to extend the motor and part cooling fan wires. This is optional. You'll still be able to use this upgrade with the original wires. However, the half of the extruder that opens will have to stay closer to the fixed half. The extra wire length would extend this distance, allowing for an easier extruder servicing. I have not extended the wires on this printer. If you want to extend the wires, extend them by at least 15 cm. I won't include detailed steps for the wire extension here. Haribo! After that, it's time to mount the carriage. First, install the bearings. Make sure the bearing space is completely clean. Dirt here can introduce misalignment in the bearings, leading to lower overall print quality or printer damage. Insert two LM8 UU bearings at the top and one at the bottom. Use a key to force the casing open. I use IGUS dryline bearings here, but you can use normal bearings as well. Insert 4 square nuts at the top bearings and screw in 4 12mm screws at the top, tightening with minimal strength. Insert 2 square nuts at the bottom bearing and screw in 2 12mm screws at the bottom, tightening with minimal strength. Clean the bearings and insert some grease over their entire inner surface. For IGUS dryline or other dry run bearings, use lightweight petroleum-based oils such as lithium grease. They are self-lubricating, but some grease helps a lot, especially with the steel rods. Now insert the nylock nut. This will prevent the idler door from loosening over time, especially when using the multi-material unit. Clean the rods with a piece of cloth or paper towel to remove residue, always a good idea. Load the carriage on the rods in the correct orientation. The two bearings should be pointing up, with their screws towards the back of the printer. If using IGUS dryline or other dry run bearings, don't worry about them being too loose at this point, we'll tighten them later. If the bearings are too tight, feel free to loosen the screws for now. We're now going to reassemble the X-axis. First, if you're using the adapted revised X-axis ends, then assemble the idler end. If not done already, have the idler wheel installed in the small idler holder with a dowel pin. I've purchased a different Gates idler here and have manufactured a little dowel pin. If using the stock idler, fix the wheel in place with a 12mm screw. Tighten until almost flush with the other side. The wheel should be easy to rotate. Insert 2 hex nuts in the little idler holder, insert it inside the idler end, and secure it with 2 18mm screws. Now install the extend idler. To make it easier to insert the rods and easier to remove them later, add some of your preferred grease. Now insert the rods all the way into the extend idler. Haribo! If you are replacing the Z-axis bearings or just adding some bearing spacers, now is a good time to do that. Do this also if you are replacing the X-ends. First remove the 4 old bearings from the X-ends if not already removed, then insert one bearing at each end, insert a bearing spacer at each end, and insert a second bearing at each end. If using the revised x-axis, at each end add 2 10mm screws and nuts for bearing tensioning. Only lightly tighten them if using dry run bearings. Add 2 hex nuts for the Z mount and repeat for the other X end. Clean the 4 Z-axis bearings and add some grease over their entire inside surface. For IGOS or other dry run bearings, use lightweight petroleum-based oils such as lithium grease. Clean the vertical rods with a piece of cloth. Make sure the vertical lead screws are relatively clean. Same for the trapezoidal nuts. Any pieces of residue can damage the nut thread. If needed, you can clean them with hot water, dry them, and then apply some grease. If using IGOS bearings for the Z-axis, use a vertical rod to test and adjust bearing compression. For the motor end, tighten until there is no play, but make sure there isn't much friction when sliding the rod. Repeat for the idler end. Now insert the X-axis assembly back on the vertical rods and the lead screws. Make sure the carriage is oriented correctly with a flat face facing the front of the printer and with the 2 bearings on the top rod. If using the bare frame, make sure the vertical frame is square. Screw back the nuts on the Z motor's axis about halfway down. Make sure they are vertically aligned, so both at the same height. Put back the screws holding the nuts in place. Don't tighten the screws too hard. You should be able to manually rotate the Z motor axis without much force. If it's too hard to rotate, it could be that the nuts are not perfectly perpendicular to the rods and you should loosen the screws a bit to get smooth rotation. They don't have to be super tight, but there should be no play. If the nut won't align, try rotating it 180 degrees. It can also be that the nuts are dirty, in which case you should clean them in hot water, dry them and reapply grease before installing. Remember how I said to make sure the printed parts are not skewed? Well, turns out in my case, the nut won't stay perpendicular to the print. I should print a replacement, but I wanted to emphasize that issues can show up at any time with 3D printing and sometimes we need to improvise. In this case, I used this special E3D invoice paper, fold it and stick it in the opening. It works for now, but I'll have to replace the part eventually. Screw back the 2 Z-axis top parts holding the ends of the Z rods. With the X-axis in a perfectly horizontal position, you should be able to manually rotate the lead screws easily. Haribo time! If you're upgrading from Mark III to Mark III's, you need to replace the PTFE tube inside the E3D extruder with a shorter one. I also recommend replacing this from time to time. You can either purchase new ones from Prusa website or manufacture your own. Make sure not to damage the extruder cables or the narrow heat break in the middle. First, remove the custom Bowden lock if previously installed, press down the black collet and pull out the Mark III PTFE tube, and insert the Mark III's PTFE tube with a pointy end forward. While pushing down the PTFE tube, pull up the black collet, then insert the Bowden lock underneath. This prevents the PTFE tube from moving up and down during prints. If not using the multi-material unit, insert the ball in the extruder body. Skip this step if using the multi-material unit. Install the FS lever using a 16 or 18 mm screw. Tighten the screw a little, remember it doesn't have a nut. Then unscrew it enough for the lever to move easily. Insert the 10x6x2 flat magnet, the smaller one, in the installed lever. If it falls out, use some glue to fix it in place. Then insert the 20x6x2 flat magnet, the larger one, in the hole to the left of the lever. It should repel the lever. If not, remove it and insert it rotated with the other side facing the lever. If it won't stay firm, use some glue to lock it in place. Move the lever to the right and carefully insert the infrared sensor on top of it, and then push it down towards the lever. It should fit and the screw hole should align with the hole above. If not, the sensor might break when adding the screw at the next step. The small and thin M2 by 8 mm screw, not to be confused with the M3 by 8 mm screw, will soon be inserted from the top through the infrared sensor. First check that the screw head can very easily slide through the hole. If not, take out the screw and the sensor and use a 4 or 4.5 mm drill bit to make the hole just large enough for the screw head to easily slide in. Don't use a very large drill bit, as the same hole will be used later for an M3 screw. Insert the thin M2 by 8 mm screw through the infrared sensor. When inserting the screw, it's easy for it to get stuck sideways. Do not force it in, as it'll get stuck completely. Instead, try to gently nudge it out and insert it again. Tighten the screw slightly to fix the sensor in place. The sensor should stay firm, but you should be able to apply some force to adjust it half a millimeter left and right without the risk of breaking it. Check that the lever can still move easily underneath the sensor. You will not have easy access to the sensor screw later. Note that the sensor pins protrude from the back. While working with the extruder body over the next steps, be careful not to bend or break these pins. Now insert a square nut in the top slit of the extruder body. If using the multi-material unit, install the multi-material lever with a 20 mm screw. The lever comes in multiple sizes, use the one marked M for medium. Make sure to hold the FS lever to the left and not break it. Tighten the screw, then loosen it enough for the lever to move very easily. I'm not using the multi-material unit, so I won't be installing this lever. If not using the multi-material unit like me, install the multi-material dummy with a 20 mm screw. This way dust will not enter the extruder from above. Gummy bears! Now onto the cable holder, break off the supports if any, then prepare it with a 16 mm screw at the bottom. We'll be adding another screw at the top later. Insert a square nut in the carriage from below and hold it there. While holding the nut, insert the cable holder and screw from behind and rotate the screw just enough for it to catch on the nut. The cable holder should have enough play to allow for the wires to be inserted from above later. Find the infrared sensor cable and pass it through the diagonal slit on the carriage. Now insert another square nut in the middle port to be used for the cable holder later. Then insert 3 square nuts in the carriage from the sides. And one from the top here. Use one 25 mm screw to connect the extruder body to the carriage at the top left without tightening. Make sure the sensor pins go through the opening and the cable is not pinched. Try holding the sensor cable in the slit. Then use 2 8 mm screws to connect the bottom without tightening. Make sure the sensor cable is still not pinched. The extruder body and carriage should lie flat against each other, otherwise the cable is pinched. Now completely tighten the 3 screws. Insert a 20 mm screw at the top right, second hole down, and tighten. I forgot about this one. If using normal bearings, simply tighten the 6 bearing casing screws enough to hold the bearings tight in place. Do not over-tighten, as it may damage the casing. If using uncompressed IGUS dryling bearings, precise adjustment is needed in order to find the optimal balance between precision and smooth movement. We'll be doing an initial adjustment now, as it's easier to do without the belt, and you'll be able to readjust them at any time. Apply a thin layer of lithium-based grease on the rods and slide the carriage back and forth to each end a couple times. This is needed even though the bearings are self-lubricating. The X-axis has to be completely horizontal for this to work. Completely relax all 6 bearing screws and tighten them very softly and equally. For example, using an Allen key without using the bend section at the end. Rotate to tighten just using your fingers directly on the key axis. Go over each screw twice. At this point they should all apply compression somewhat uniformly. The carriage should slide easily. If the bearings are new, it can happen for them to be too tight already and prevent smooth movement. In that case, turn all 6 screws counterclockwise 90 degrees to relax the casing and check again. Repeat until you get smooth movement. There should still be some friction compared to the stock bearings. On the other hand, if the carriage slides too easily, check for play in the bearings. Using moderate force, twist the carriage in various directions and check for any play at the bearings. You can feel the play in your hand or see it. If there's play, you can turn all 6 screws clockwise 90 degrees to tighten them and check again. Repeat until you find the sweet spot between bearing tightness and sliding. I suggest not getting them super tight. Aim for a balance between ease of sliding and bearing play. A very little bit of play under force shouldn't have any noticeable impact on print quality. Initially the bearings will not be perfectly aligned with the axis and you may have to retighten them after a few prints and then from time to time if the bearings start having play again. This is because the printed parts are not perfect and will deform with time to fit the position of the bearings. With the x-axis in a horizontal position, make sure you can easily slide the carriage from one end to the other. If it can't reach one end, then it's possible that something was not installed correctly and needs fixing. Gummies, woohoo! The new fan doesn't have a long enough cable, even with the included extension cable, and the connector is thicker and won't fit. You'd have to either have a long enough extension cable of 70 cm or more with the correct connectors and plug it into the new fan, so no soldering is involved, and then you can skip the rest of this section entirely. The second option is to use an extension cable that does not have the correct plug and use some jumper wires to connect it to the board. Easy to do, but the wires can easily jump out. This way the stock fan wires are unchanged, but you'll still have to adapt them if you use the case fan option. Be careful not to flip them when connecting to the main board. And the third option, manually extend wires. I won't be covering soldering, but I will show a wire splicing method where you can skip the soldering step. What I've done was to cut the wires on the 40 mm fan, leaving only about 5 cm of wire on it, then plug the extension cable from the new larger fan into the fan itself and cut the other end of the extension cable. Keep about 20 cm and leave the rest of the wire with the other end, just in case you want to use it later for other applications. This way you will have a connector close to the fan. You can remove the protection from the extension cable, as it will make it easier to fit all the wires in the extruder. Then you're gonna have to connect and solder the 6 wire ends. Alternatively, you can do something similar but with a fan cable instead of its extension, so you don't have another connector at the extruder end, like I did on my other printer. In this case, you'll need a piece of cable with 3 wires to have a long enough final cable. Here's how I do wire splicing in general. If using heat shrinking tubes, for each wire pair insert a 5 cm piece on one of the wires. You can insert an additional wider tube on top so you can cover all 3 wires later. Use the wire stripper to strip all cut wires. Now splice each pair. Use your favorite method. One option is to align the wire ends in an X, like so, then twist one around the other once. Make another X and twist again. Gently pull from all 4 ends to tighten the knot. Then twist the ends like so. Double check the pairing either visually by checking colors and/or using a multimeter. At this point you can solder the wires for better contact if you want and know how to do it properly. Make it small, as soldered wires tend to break next to a large soldering blob as the cables will be constantly moving. Make sure that each pair of wires has a heat shrinking tube inserted at least several centimeters away from where the soldering will take place. Be careful not to hurt yourself, do not inhale the fumes, and check each pair for strength. If using the heat shrinking tubes, slide them over the solder sections, completely covering the stripped wire. Using the heat gun, apply heat on the tubes until they shrink. Be careful not to hurt yourself or burn or melt other objects or printer parts. If using electrical tape instead of heat shrinking tubes, carefully cover each solder section with tape in a spiral fashion, making sure to completely cover the stripped section in a tight and thin layer of tape. If using the wider shrinking tube, pull it over the connections and use the heat gun to shrink it. You should end up with something like this. Now you can reuse the existing 40mm fan for cooling on the mainboard. If using the bare frame upgrade, the Universal Zaribo Einzi box comes with a fan cover where the 40mm fan can be used. The Einzi Rambo mainboard has a dedicated port that can be used to power the fan. Gummy bears! First, break the support from the shroud. The shroud is almost identical to the stock Mark III S1. Insert a square nut in the shroud, then use a 12mm screw to connect the shroud to the fan duct. Then align the shroud and tighten the screw. It will be a bit more difficult to access it later. Find the wire clip on the fan and push it out carefully, making sure not to damage the wires. This is optional for a cleaner look, but the clip was preventing you from pulling on the wires and breaking their ends, so if you remove it, be careful in the later steps. Use the Phillips screwdriver and the 4 screws that came with the fan to mount the new 60mm fan on the fan duct. The cable should come out of the fan from the top right on the fan duct side. Alternatively, you can try to use the fan rubber connectors instead of the screws, but I wasn't able to install them easily. The fan duct is fragile, so be careful not to break it. As a note, the screw next to the fan wires will be hard to remove later, so if you plan on removing the fan for whatever reason, then what you can do is install the screw backwards using a thin enough screwdriver that goes through the fan screw holes. Now add the PitStop fan grill. Use 4 more screws or rubber connectors. Do not tighten the screws too hard, as this could push the grill against the fan blades. Make sure the blades can rotate easily. You can add some spacers if needed. If you are using the bare frame upgrade and you happen to have extra screws lying around, then you can use those for a more industrial look. You might have to enlarge the holes with a drill bit. Now insert 2 square nuts in the lower part of the fan duct on the other side. Position the blower in place and connect it to the fan duct using 2 20mm screws. Pass the wires through the slit. Be careful as the wires can easily break off. Gummies! Insert 2 square nuts at the top of the fan duct, then remove supports on the motor plate if not removed already, and align the motor plate and the fan duct and connect them with 2 8mm screws. Then insert 1 more square nut in the motor plate on the right side all the way in. Screw in a 16mm screw from below. There are 2 holes, make sure it goes in the round hole and not the rectangular one next to it. It's easy to insert it in the wrong place. Use the key with the ball end. Now pick up the motor and hold it with the wires protruding to the left and the gears pointing ahead. Clean the top face of the motor with IPA and a piece of cloth to remove any grease. This is where the heat will be transferred to the radiator. Then clean the radiator top part with IPA. Insert the radiator in place. Make sure it's oriented with the main slits towards the large fan. Apply thermal paste. I'll make a big X. Don't spread it for now to avoid air pockets. Align the motor in place with the wires protruding to the right, not down as with the original extruder. Connect the motor with 4 screws, 2 8mm, 1 12mm and 1 16mm. Then tighten them, starting with 1 diagonal. Push the radiator inwards and then up towards the motor to spread out the thermal paste. There is a ramp at the back to help push the radiator up when pressed inwards. Use a flat screwdriver and make sure not to break the thin printed part below. Insert a 12mm screw here to hold the radiator up. Now, time to adjust the hob gear. For this, use the Bondtech alignment guide. Insert a piece of filament in the guide, loosen the Bondtech gear on the motor, align the Bondtech gear with a piece of filament, and then tighten back the gear screw. You may have to make small adjustments later if you get grinding on the filament. Gummy bears! Insert 3 square nuts and 3 12mm screws in the extruder body like this. Screw in the screws just enough to catch on the nuts and don't tighten at all. Similarly, insert 3 square nuts and 3 12mm screws in the motor plate like this. Again, screw in the screws just enough to catch on the nuts and don't tighten at all. Take the 6-cylinder magnets. To make sure they are oriented correctly, link them in a train or tower formation. When inserting them, make sure not to push them too far in. Insert 3-cylinder magnets in the extruder body. Disconnect them one by one from the group and insert them in the same direction without rotating them. Do not insert them fully. Let them protrude about 1 or 2 mm from the front. Use the round magnet guide. If you can't push them with moderate force, use a 6mm drill bit to enlarge the holes, making sure you don't damage any wires and don't drill too deep. Be careful not to hurt yourself or damage the infrared sensor cable. Now flip over the magnet train or tower to change the magnetism direction for the remaining magnets. Insert the remaining 3-cylinder magnets in the motor plate. Make sure the magnet fronts are clear with no metallic particles or small magnet fragments. Insert the E3D extruder in the extruder body. Be careful with the wires as they can easily break if bent at the base. If you have an identical spare E3D cold end, you can use that instead. Press it in firmly. You are about to connect the two printed parts. The magnets will tend to snap, which can fracture them. Try to prevent the parts from colliding violently and be careful not to get your fingers pinched. Done correctly, the process should be slow and controlled. Hold the extruder body and the motor plate from the sides. Turn the motor plate 90 degrees and put it in contact with the extruder body on the right side. Slowly rotate the motor plate towards the extruder body until the magnets touch. If a gap remains between the magnets, try realigning the parts. The 3 magnet pairs should now be holding the parts in place. If the magnets start repelling each other, it means they were installed in the wrong orientation. Remove the ones installed incorrectly and reinstall them. Slowly press the motor and the extruder body against each other until the parts are touching on the left side and at the extruder radiator. Press them firmly but don't use excessive force. With the parts pressed against each other, tighten the magnet screws for the pairs of magnets at the top and the right side, just enough to keep the magnets from moving. Not much force is needed. Do not over-tighten them, as this might cause the parts to break. The E3D extruder should be fixed in place, and by applying little force you shouldn't be able to move the nozzle at all in any direction. If the nozzle has a little bit of play, then the extruder will still work, but prints will not be perfect. Let me know if this is the case. To open the assembly, hold the motor from the sides and try opening the extruder by pulling from the left side and then pulling the whole part away. Open the extruder and take the extruder column out to avoid damaging it. There is one last pair of magnets to tighten, but their screws were not accessible earlier. If it looks like they haven't moved, then simply tighten them now. Alternatively, you can close back the assembly without inserting the E3D extruder, make sure the magnets are aligned and try to tighten them from below through the round radiator hole. It's a bit difficult to locate the screws. Now close the assembly and look through the top filament hole. The motor gear should not be in the way. Adjust the motor Bondtech gear position if needed. If not using the multi-material unit, the metal ball might be in the way and you'll need a different way of checking. Now for a final check, put the E3D extruder back and close the assembly. Make sure neither the E3D extruder nor the motor plate can move easily. Haribo bears. Now onto the Bondtech idler. First, remove the Bondtech idler from the previous idler door if you haven't done that already. This can take significant force. Be careful not to lose the tiny parts. There should be one axis, 2 small bearings and one outer Bondtech gear. If the idler doesn't rotate very smoothly and it feels like binding, then you can clean it up and apply a little bit of grease. Find the correct printed part, either the simple door or the one with an extension at the top for the multi-material unit. If you plan using the multi-material unit in the future, you can directly install the multi-material version of the door. The only downside is that it won't fully open, which is not really a big problem since the whole extruder opens, but can make gear alignment harder to perform in the future. Insert the two bearings inside the Bondtech gear and align it inside the new printed part. Make sure it's correctly oriented with the large teeth towards the left. Carefully insert the axis through the printed part and the bearings and make sure the axis is fixed at the other end as well. Use the chamfered end as it is slightly wider for easier insertion. Check that the gear can rotate easily. Use a 25mm screw to connect the idler door. Tighten the screw to make sure it pulls the nylock nut on the other side. Then loosen the screw until the door can rotate a little bit without much resistance. Insert a square nut in the idler door and add a spring to a 40mm screw and screw it until it catches on the door nut. From now on, when connecting the motor plate to the extruder body, there is a chance for the Bondtech gears to hit each other or the filament, and you may have to wiggle the parts a bit until the gears slide past each other. You can optionally install a pneumatic fitting at the top. The point where the filament enters the extruder is designed for a PC4 M10 fitting. You can either install a real fitting or a printed dummy fitting. When using a Bowden tube or the multi-material unit, the metal fitting is required. Screw in the fitting using a 10mm socket wrench, a key, adjustable wrench or pliers. Do not over-tighten as this can break the printed part. Gummy berry bows. What? Next, we'll take care of the front cable management. Pass the cables from the fans and from the motor in between the horizontal rods. Connect all cables to the mainboard. The heating cartridge, the thermistor, the infrared sensor, white to the left, bottom row. The Pinda sensor, the extruder motor, the extruder fan, and the part cooling fan. Also connect back the X-axis motor. Except for the heater cartridge and the thermistor, pass all cables through the gap at the top of the cable holder. Screw a 20mm screw at the top of the cable holder. Tighten the cable holder screws a little while making sure no wire is pinched and all cables fit through the now enclosed channel. You don't have to fully tighten the screws, you should still be able to pull the wires back and forth. Insert the thick nylon filament in the carriage, be careful not to break the thin parts of the carriage, and place the other end at the mainboard case. Now we're gonna measure how much spare cable you can have for the detachable part of the extruder. The motor cable and the part cooling fan cable are the shortest ones. Gently pull them towards the extruder, making sure to align them with the nylon filament to make sure that there's enough cable left at the back. This way there will be enough wire between the extruder and the case when putting back the textile sleeve. Be careful with the part cooling fan, as its wires can easily break off at the base. I already broke mine once and had to solder them back. Without pulling more, pass the motor cable and the part cooling fan cable through the channel on the right side of the extruder. Pass the large fan cable through the channel at the back of the motor. If the large fan cable is comprised of only one part with no connector in the middle, then leave as much extra wire as the motor and the part cooling fan have, and then pass the rest through the slit at the right, pulling from behind the extruder to straighten the wires. If the large fan has an extension cable, then position the connector to the right of the motor and then pass the rest of the cable through the slit at the right, pulling from behind the extruder to straighten the wires. Insert a piece of filament in the small hole at the right of the wire channel towards the front and cut all but 1 mm of protruding filament. Well, maybe not that hard. This will prevent wires from getting out of the channel when opening the extruder. Use a zip tie to connect the two fan cables and the motor cable together as they exit the wire channel. Leave some gaps so that the zip tie is not forced against the motor plate. Cut the excess. If you later notice that your cables could get pinched here, then feel free to trim this corner. Add a second zip tie a few centimeters from the first one. If there is a cable connector there, add the zip tie right after the connector. Cut the excess. Alternatively, you can use a large enough shrinking tube like I've done for my other printer. It is a bit large, so the zip tie variant might be better. Insert the extra length of the cables at the front in the space between the motor radiator and the part cooling fan. Then, while holding the Pinda probe below the extruder, insert its cable in the Pinda location through the slit. First, make sure the print supports are taken off. Slide the Pinda probe up until it is about as high as the bottom of the shroud. Insert a square nut from below and use a 12 mm screw to slightly fix the probe in place. Insert the probe cable in the wire channel and pull it from behind the extruder to straighten it. Without pinching any wires, insert a piece of filament in the second small hole at the right of the wire channel towards the back and cut all but 1 mm of protruding filament. Make sure to have the Pinda cable behind it. Insert the infrared sensor cable in the infrared sensor. Then pull the infrared filament sensor cable down and then from the back to straighten it. Only leave a small part at the sensor, about 1 to 2 cm. A longer wire can be caught between the bearing casing and the frame, damaging the wires and causing calibration errors. Double check the extruder cables in the wire channel. If the Pinda cable or any other cable is too loose here, it may get crushed between the extruder and the extend idler, causing cable damage or printer calibration errors. Haribo. And now to fix the cables at the back. First, tighten the cable holder screws. Make sure no wire is pinched. All wires, except for the ones going to the E3D extruder, should go through the one slit at the back. Insert 2 zip ties to the top of the cable holder. Gently pull all the extruder cables towards the main board to make sure that the cables are running parallel to each other with no loops. Wrap the textile sleeve around the wires and the nylon filament at the back of the extruder and tighten it around the wires for the first 10 cm, pushing it towards the extruder. Close the 2 zip ties and tighten them, then trim any excess. If not done already, insert the E3D extruder with the wires pointing towards the back, then close the assembly. Insert 2 zip ties at the bottom of the cable holder. You may have to flip the printer over for easier access, just be careful. Close and softly tighten the zip ties around the wires coming from the heating block. Then trim any excess. You can allow for a little bit of play here. Then insert these wires in the textile sleeve along with the other wires. You can leave a little bit of slack if you want to take out the extrusion column easily. One thing to note about these lower cables is that if they have too much of a slack, they may get caught in the bed sheet alignment guides that protrude from the bed. If you want to have more slack at these wires, then what you can do is trim these alignment guides like my brother did, leaving just a little bit for the sheet to catch on. I haven't had this issue, so I haven't shortened mine. Now close the textile sleeve around the wires and tighten it. Gently twist the textile sleeve to further tighten it. Connect the end of the textile sleeve and nylon filament at the mainboard case. Tighten everything with the case screws. If the universal Zaribo INZ box is used and the fan cover was printed, then connect and solder the red and black fan wires to a 2-wire connector. Follow the steps on connecting and soldering wires earlier. Note that the yellow fan wire is not used and should be insulated with heat shrinking tube or electrical tape. Use 4 spare M3 hex nuts and 4 20mm or 18mm screws to mount the fan with the fan cover on the outside. Do not over tighten or the fan cover will break. You can connect the fan here. Original black wire up. Double check that all wires are organized and connected. Then close the mainboard case. And now it's time to install the belt. Insert one end of the belt in the belt tensioner, leaving 2 teeth at the end protruding from the tensioner. Insert a square nut in the carriage and connect the tensioner to it with a 40mm screw. Only screw it in enough to catch on the nut. Pass the other end of the belt over the motor gear and back under it. Make sure the belt is not twisted and go straight to the motor gear without touching anything on the way. Pass it through the back of the extruder without twisting it. Pass the belt by the idler at the right and back over it. It can help to bend the end like this. Make sure the belt is not twisted and go straight to the idler wheel, going through the belt slit in the extruder and not touching anything on the way. Insert the belt lock in the carriage and nudge it to the right. Tension the belt a little by hand and insert the end in the belt lock. Make sure the belt is not twisted and goes directly from the idler wheel to the carriage. Tighten the belt tensioner screw until the belt is properly tightened. If there is not enough room for the idler to tension the belt, loosen it and reposition the belt in the belt lock in a tighter position. Then tighten back the belt tensioner screw. Tighten the belt using your favorite tightening philosophy. In general, the belt should be tight enough to prevent it from skipping on the motor gear and minimize ghosting. On the other hand, too tight of a belt can damage the motor bearings on the long run, or it can make the carriage harder to move. Some say the belt should vibrate at a certain frequency when plucked with the carriage all the way to the right. This can be measured with an oscilloscope app. I use Spectroid on Android. What frequency is best is unclear. I aim for about 100 Hz for plucking the top part of the belt. The motor gear should be aligned with the belt. Just in case, double check that the belt is not strongly pushing towards the motor or away from it at the gear when moving the extruder left and right. If it does, you need to reposition the motor gear. Haribo. Now follow the usual instructions for adjusting the Pinda height position. Place a sheet of paper on the bed to protect the nozzle. Manually move down the extruder by rotating both Z motor axes simultaneously. Leave just a little gap below the nozzle. Move the extruder left and right and try to level it by adjusting each Z motor independently, and lower the nozzle just enough to grab on the paper. Position the extruder in the middle and place the thin end of a zip tie under the Pinda probe. Loosen the Pinda screw and push the probe down until it pushes against the zip tie. Then tighten back the Pinda screw. Make sure the fan shroud is horizontal. If you can't straighten it, take off the front of the extruder, carefully insert a hex screw through the fan grill and the fan blades, and loosen the shroud screw. Align it correctly, then tighten back the screw. And we're pretty much done with the assembly. And now for the final checks. Insert a piece of filament in the Bondtech gears from above and adjust the idler door tightening screw until its head is slightly below the surface of the printed part. Check that you can easily open and close the extruder. Always open from the left and rotate like this. When closing, align on the right side and rotate back, making sure the wires don't get pinched. Now remove the piece of filament. Now test the magnetic system. There should be no sign of the extruder opening by itself. Test that the extruder would not open on a print crash. Pull from the center bottom of the shroud towards the front with moderate force so as to not break the shroud. The extruder should not fully open. Then add some grease on the X and Z rods as well as the lid screws if you haven't done that already. Make sure you don't add grease on the belt or the build plate. Make sure the printer lies on a flat surface. If using the bare frame upgrade like I do, check that the angles are perfectly square. Take a moment to clean the build plate. If you have the textured build plate, scrub it with IPA. Non-PLA filaments can adhere too strongly to a clean sheet and risk ruining it. If in doubt, apply build plate adhesives. This should provide enough adhesion for several prints, unless you leave your fingerprints on it. Next, plug in and power on the printer. If the printer was upgraded from Mark III to Mark IIIs during this upgrade, you need to flash the printer firmware. There are various resources explaining how to do that. Temperature reading is correct. If you are upgrading MMU2 to MMU2S during this upgrade, you need to flash the multi-material firmware in a similar way. Now check the infrared sensor. To do this, in the printer menu navigate to Support Sensor Info. Next to the infrared sensor, you should see the value 0. If it is 1, open the extruder and rotate the infrared sensor to the left. There is about 0.5 mm room of rotating it. Close back the extruder to get a good reading. If this does not fix the issue, check that the sensor parts are assembled correctly and can move easily. If still not fixed, check the troubleshooting section in the description. Next, insert a piece of filament in the extruder. For the multi-material version, we have to push it in between the gears. The infrared sensor should read 1. If it's 0, open the extruder and rotate the infrared sensor to the right. There is a 0.5 mm room for rotating it. Close back the extruder to get a good reading. If this still does not fix the issue, check that the sensor parts are assembled correctly and can move easily. If using the multi-material unit, there are extra levers you can try. If still not fixed, check the troubleshooting section in the description. If using the multi-material unit, connect the tube from the multi-material unit to the extruder. Run the calibration wizard by navigating to calibration wizard and follow the entire procedure. On success, happy printing. On error, happy troubleshooting. And this is my first print, the crooked x-axis I need to replace. If you just finished the installation process, please take a moment to share your experience while it's fresh in your mind. Do this especially if you encountered issues or got stuck. See the short survey link in the description. And that's all. Congratulations if you managed to follow along, and if you got stuck at any point, check the description for the best ways to get help. If the printer works, try and print again the test print and compare it with a copy printed before this extruder change. Use the same settings and material. And until next time, be awesome!